We need to evaluate the sum from r equal 1. We need to evaluate the sum from r equal 1 to n of, writing that down again, tan r theta sine 2r theta, tan r theta sine 2r theta plus the cos of 2r theta. The cos of 2r theta. And don't tell me we're summing from 1 to n. If they say summing from 1 to n, let's see. Yes, we're summing from 1 to n. So let's work this out, Marika. Now, the first thing I observe is if we were to cross multiply this right here, so what you'd end up get is 1 minus the cosine of 2n theta. If you cross multiply it, 1 minus the cos of 2n theta is equal to tan n theta times sine n theta, don't it? Times sine n theta, right? Times sine 2n theta, right, Marika?
Yes, sir.
And so if we were to bring over the cos 2n theta, we'd end up get 1 is equal to the cosine of 2n theta plus the tan of n theta times the sine of 2n theta. So what am I trying to say, Marika? If you replace n with the letter r, just replace n with the letter r. If you replace n with the letter r, the same thing, Marika, all of this just equal to 1. Yeah, man, so what we're trying to say, all of this here, so equal 1. So this is just the sum from r equal 1 to n of that is 1. And the sum from 1 to n of 1, you're just adding 1 n times. So the answer just n. That nice, though. Answer just n. That nice, though. Right? So cool with this? Nice. So the answer is just n. All right? So this works out to just be n. All right? Cool with this? Cool with this, Marika? All right. So now we have the last part now to do. And this is just module 3 now. And module 3, easy part. All right, so let's go to module 3. So we need to evaluate this now. So they tell us now, this is module 3. Module 3, evaluate the limit as x approaches, what is that? The limit as x approaches -2. Evaluate the limit as x approaches -2 of, this is now x squared plus 5x plus 6, x squared plus 5x plus 6. And this is, of course, being divided by x squared minus x minus 6. Now, we can do this by the factorization method, or we can do it using L'Hopital's rule. Just in the interest of time, we're just going to use your preferred method, L'Hopital's rule. We're going to differentiate the numerator to get 2x plus 5, and then we differentiate the denominator to get 2x minus 1. And then now we just plug in the -2. Plugging in the -2, we're going to get 2 times -2 plus 5, and that is going to be divided by 2 times -2 minus 1. So what we end up getting now is -4 plus 5, and -4 plus 5 is 1 over Negative 4 minus 1, which is negative 5. So the answer is 1 over negative 5, or negative 1 over 5, however you want to put it. All right, so that's that. 4 marks to the nothing, negative 1 over 5, right? Right, Marika?
Yes, sir.
Cool. So it says now part B, the function f is defined on real numbers, and it says we're supposed to find f of 2. So to find f of 2, all you need to do is plug 2 into where the function is defined. So where you see equal to, this is where we see the equal to. So we're going to plug in 2 here. So 2 squared plus 1 is 3. That's f of 2. All right, that's all you do to find f of 2. Now, the next part is we need to find now the limit as x approach 2 from the right-hand side. Now, to find the limit as x approach 2 from the right-hand side, that is when x is bigger than 2. When x is bigger than or equal to 2, right? So we're going to plug in 2 again in this side, and that's going to also give us 3. Cool with this, Marika?
Yes, sir.
No, minus means from the left-hand side. So we're going to plug in 2 in this one now when they want limit from the left. So plugging in 2 in this one right here, that would be 2 times b is 2b plus 1. Nice. Now, Marika, look how they might give you 4 marks for the next part. Now it says find the value of b if f is continuous. If f is continuous, then the limit from the left equal to the limit from the right. So all you'd end up do is set 2b plus 1 equal to 3. The 1, bring over the 1, you get 2b equal 2. So you end up get b equal 1. That's it, b equal 1. For it to be continuous, don't it? 4 marks for that, you know. I want to do nothing, though. That nice, though.
Mm-hmm.
Nice. All right. Now this is part C now, Marika. So far realize module 3 start out nice. So let's copy this part. I don't want to copy it all the way over there. All right, you keep bringing off there. I don't know. So I'm just going to copy the curve. It tells us that the curve passes through the point T, which is 1, 2, and it has a gradient being 7 at T, and they tell us that the line x equal 1 cuts the x-axis at M, and the normal to the curve cuts T at the x-axis at N. So first thing we need to do is find P and Q. All right, so let's go ahead and do that. So just to copy this, we're just gonna remove these 4 marks right here and the 2 marks so it don't mess up what we have. So the curve is px cubed plus qx squared plus 3x plus 2, and it passes through the point T being 1, 2. So now, Marika, what they're virtually telling you is if it passes through the point T, right? You know a point on the curve. So basically, you know when x equal 1, you know that y is 2, don't it? Right? When x is 1, y is 2, don't? So we can plug that into the curve now. So when x is 1, y is 2, we're going to get 2 is equal to p times 1 cube plus q times 1 square plus 3 times 1 plus 2. Right? Right, Marika? You cool with this?
Yes, sir.
So now we set up our equation. We know that 3 plus 2 is 5. Bring over the 5 over here, that's negative 3. So negative 3 is p plus q. Now, Prio, they make the question even nicer now. What they say now is that its gradient at t is 7. So, Marika, to find gradient, we differentiate. So, if y is px cubed, dy by dx is equal to, carry down the power, we're going to get 3p x squared. Then we'll differentiate qx squared, we're going to get plus 2qx. And then when we differentiate 3x, we just get plus 3. Nice, so that's the gradient function. This is dy by dx. Now, Marika, it tells us that the gradient is equal to 7 at the point 1, 2. So we can plug in when x is 1 in here and set it equals 7. So we're going to tell them 3p times 1 squared plus 2q times 1 plus 3 equals 7. 2q times 1 plus 3 is equal to 7. So now what we end up having now is 3p plus 2q. I can bring over the 3 to the other side. 7 minus 3 is 4. So now we have the two equations, right? Cool it this? Cool it this, Marika?
Yes, sir.
All right. Now, once we have this equation and this one, right, we can just solve them simultaneously. So now this right here, we have p plus q equal -3. So what we can do then is multiply through the first equation by 3, because you know that's my preferred way, elimination. So 3p plus 3q is 3 times minus 3, that's -9. And then this right here now is 3p plus 2q, and 3p plus 2q is equal to 4. So all we need to do now is subtract these two equations. By subtracting these two equations, we're going to get 3q minus 2q, that is just q, and then minus 9 minus 4, that's -13. So that gives us q. Now once we get q, if q is -13, come back in this equation. Minus 3 is p minus 13. Bring over the 13 over here, and so p equal 13 minus 3, which is 10. So that's 10 and minus 13. So that's just a simultaneous equation, and they give 6 marks for that simultaneous equation. So p is equal to 10 and q is equal to -13. Cool it this? Cool it this, Marika? Now it says we're supposed to find the equation of the normal. We want to find the equation of the normal at t. Now, Marika, they gave us the gradient of the tangent. The gradient of the tangent is 7. Sorry. So since the gradient of the tangent is 7, the gradient of the normal is -1/7, right? -1 over the gradient of the tangent, right? Right? And so the equation of the normal is then going to be given by y minus the y value at the point. Remember at t, the point given is 1, 2. So it's y minus the y value at the point. And that's equal to the gradient, which is -1/7 times in bracket x minus 1. All right, and so now what we're going to get is y is equal to, we can bring over the -2 over here. We're going to get -1/7 times x. Then this is going to become +1/7. Then we'll bring over the 2, it becomes +2, but 2 is really 14/7. So this allows us to get that the normal is y is equal to -1/7x plus 15/7. And this is the normal. All right, so that's the equation of the normal. Cool it this? You cool it this?
Yes, sir.
This is the normal. All right, nice. All right, so that is the normal right here. All right, so the normal is y is equal to negative 1 over 7 x plus 15 over 7. Now, Marika, here's the last part of question 5. It tells us that the normal to the curve t cuts the x-axis at n. The normal to the curve cuts the x-axis at n. All right, so now what do we know about the x-axis? We know, Marika, if you have a line, right? Let's say this is the normal of the curve. This is the line. This is the line y equal minus 1 over 7x plus 15 over 7. Now, where it cuts the x-axis, we know the y value is 0. That's all. So first we need to find n. Before we can find the length of mn, it's easy to find m, right? Because it tells us that the line x equal 1 cuts the x-axis at m. So we know what m is already. We just need to find n. All right, so we need to find n. So to find n now, we put y as 0. So we put y as 0. So we get 0 is minus 1 over 7 times x plus 15 over 7. We can multiply through by 7 to get 0 is minus x plus 15. And so what we end up getting is x equal 15, right? Pull it this, x is 15. So this is the point n. N is the point, 15, 0. We pull it this, Marika.
Yes, sir.
Now we need the point M. Now Marika, hear what they said. They said the line x equal 1 cuts the x-axis at M. So the line x equal 1 is just a vertical line like this. This is the line x equal 1. This is the line x equal 1 and it cuts it at M. So M is going to be the point 1, 0 without a doubt. M is the point 1, 0. So since we know that n is the point 15, 0, I will know that m is the point 1, 0, then we can find the distance nm. So the distance n times m, the distance n times m is this length right here. To go from m to n, Marika, we change in x value is 14. So mn is just 14, that's the distance. All right, so mn, we can just put right here that mn is 14 units. Pull it this. We call it this, Marika.
Yes, sir.
All right. All right. Nice. All right. So now we're just at the last question now. Question 6. Then we finish. All right. So this question right here, it says the diagram below is not drawn to scale, and it shows us a sketch of the section of the function f of x. F of x is x times x squared minus 12, right? And it says it passes through the origin O, A, and B. These are stationary points of the curve. And it says we're supposed to now find the stationary points A and B. All right? So we need to find A and B. So now if we're supposed to find A and B, what happens at a stationary point, Marika? So f of x is equal to x times x squared minus 12. At a stationary point, dy by dx equals 0, right? Right, Marika?
Oh, yes, yes.
Yeah, at a stationary point, dy by dx is 0. So we can expand in this to get x cubed minus 12x. X cubed minus 12x, this is f of x. F of x is x cubed minus 12x. So we can tell them at a stationary point, at a stationary point dy by dx equals 0. All right, that's what we know at a stationary point. So in this case, we just need to differentiate. And so that's going to tell us then we're solving 3x squared minus 12 equal to 0. That's f prime of x. That would be dy by dx. All I did was differentiate to get my dy by dx. And my dy by dx is just 3x squared minus 12. All right, so now since this is f prime of x, this is f prime of x. All right, so now 3x squared is equal, 3x squared minus 12 equals 0. We can bring over the 12 now to get 3x squared is equal to 12. And so we can divide through by 3, Marika, to get x squared is equal to 4, don't it? This makes sense,
Yes, sir.
right? And so the two stationary points we get is when you square root, you get plus or minus. So x gonna equal to 2 or x equal to minus 2. Now we can find the y value. To get the y value, Marika, we're just gonna plug in when x is 2 right here. Sorry about that. We're just gonna plug in x is 2 right here. So plugging in the 2 right here, we're gonna get 2 squared, which is 4. 4 minus 12 is 4 minus 12 is minus 8. Minus 8 times 2 is minus 16. Then when x is negative 2, I will plug in negative 2 here. Negative 2 squared is 4. 4 minus 12 is negative 8. Negative 8 times negative 2, that's positive 16. So therefore, the two stationary points then, Marika, are 2, negative 16, and minus 216. Pull it this, minus 216. Pull it this, Marika.
Yes, yes, sir. Understand.
Nice. So right here, so now we just can put them on. By the way, Marika, remember the negative coordinate, that can be the one with A. So A are the one with a negative 216, and B are the one with a positive coordinate for X, and this are 2 minus 16. Now here with them say now, them say, find the equation of the normal to the curve at the origin. So Marika, this would be the tangent to the curve at the origin. The tangent to the curve at the origin would be this. That would be the tangent. But they don't want the tangent. They want the normal to the curve at the origin. All right, so first thing we need to find is the gradient of the tangent at the origin. So we can then find the gradient of the normal. So this is f prime of x. So we know that dy by dx, or f prime of x, it is equal to 3x squared 3x squared minus 12. Now at the origin, Marika, x equals 0. So we're going to tell them at origin, x equals 0. So when x equals 0, Marika, what we're going to get is that the gradient of the tangent is going to be equal to 3 times 0 minus 12. That's the gradient of the tangent at the origin, which is negative 12. But if the gradient of the tangent is negative 12, then the gradient of the normal, Marika, is 1 over 12. Now, if the gradient of the normal is 1 over 12, what we're going to get then, Marika, is y minus the y value at the origin, Marika. Origin is 0, 0. So this is just telling us that y is equal to 1 over 12 times x. All right, it's really y minus 0, but since we know the origin is 0, 0, we know c is 0, so this is going to be the equation of the normal at the origin. In this case, we end up get, that's why I just 2 marks, because them know say you know c already. So that's why I 2, makes sense. Y is just equal to 1 over 12 times x, because they know that c is 0. So they must say, why give you 4 for that? Make sense? Make sense for just 2, right?
Yes, sir.
Nice. So now the next thing they want now is find the area between the curve and the positive x direction. So Marika, what they want is the area between the curve and the positive x direction. This area right here, they want this area. So to find this area, Marika, first thing we need to know is we need to find this x value because we're going to integrate from 0 to this value to get the area. Now, in order to find this value, Marika, this occurs when y is 0. So first thing we need to do is set f of x equals 0. So first thing we're going to do, Marika, is set f of x equals 0. So setting f of x equals 0, remember, f of x is x times x squared minus f of x is x, f of x is x cubed minus 12x, or x times x squared minus 12. If we're setting this equals 0, Marika, there are going to be three possible roots. We're going to get either x equals 0 or x squared equal 12. If x squared equals 12, Marika, we can square root it to get x equal to the square root of 12. And remember, you get two answers, plus or minus the square root of 12. What does that mean? That means, Marika, this root here so are the positive square root of 12. The root over here so would have been negative the square root of 12. But we're not business about the negative one, we're only business about the positive one, the positive root of 12. So all we need to do now is integrate the curve from 0 to root 12. So now, Marika, what we're going to get then is that the area is equal to the integral from the x value being 0 to root 12 of the curve, and the curve, remember, is x cubed minus 12x. Yeah, man, x cubed minus 12x dx. So now we're going to integrate this curve now, and what we're going to get is x to the 4 over 4 minus, this is then 12x squared over 2, and we are integrating from 0 to root 12, right? Right, Marika?
Yes, sir.
Nice. So now we just need to plug in root 12, plug this in our calculator. All right, so I'm just going to plug it in my calculator. Let me bring it up in the calculator. This is now the root of, I left off something. It's the open bracket, the root of 12, and that part is being raised to the 4th power. Then I divide that by 4. Then I subtract. This was 12x squared over 2, which is just 6x. So it's 6 times the root of 12 square. Then I close up that bracket. Negative 36. So I get negative 36, Marika. This is negative 36. But Marika, area cannot be negative. Area cannot be negative. Area cannot be negative. And so the area is 36 units square. It's just the positive of the value, 36 units square. All right. The only reason why it's negative, Marika, is because we're below the y-axis. We're below the x-axis, sorry. So that's why I come out negative. If we did it above it, that'd be positive, but below is negative. All right. So the area is positive 36. Cool it that, Marika? Area is 36 units square. That's the area, 36 units squared. Cool it is? Cool it is, Marika?
Yes, sir.
Nice. Now, this question now. All right, so some more integration to Marika, bag of integration, but them really easy. It says use the result that the integral from 0 to pi of x sine x is equal to the integral from 0 to pi of pi minus x sine x dx. So then say use the result. So let me see. So Marika, we have that is integral from 0 to a of x sine x. Well, let's not start there. The integral from 0 to a of, we're writing down the rule first. The integral from 0 to a of f of x, writing down the rule that we're going to use, that's very important. The integral from 0 to a of f of x dx, they tell us that this is equal to the integral from 0 to a of, in bracket, a minus what? F of a minus x, sorry, f of a minus x. F of a minus x. All right, this one might have a little spice to it, we don't know yet. We're going to use this rule to answer the question. So now Marika, tell we say, we need to use it to show us that the integral from 0 to pi of x sine x is this right here. Let's go ahead and do that. So we need to integrate from 0 to pi of x sine x dx. All right, this is what we need to do. Now, Marika, if we were to follow the rule, right, anywhere x is, we can replace x with a minus x. So what this is saying then, Marika, is that this is equal to, looking at f of x, f of a minus x. So I'm going to rewrite this as the integral from 0 to pi of, where x is, rewrite x with a minus x. A is pi minus x times the sine of, in bracket, a minus x, which is pi minus x. Nice, dx. What the question done, Marika? Because Marika, the sine of pi minus x is the same as, the sine of pi minus x is the same as the sine of x. The sine of pi minus x is the same as the sine of x. This part, the sine of pi minus x is the same as the sine of x. So this can work out to be the integral from 0 to pi of pi minus x times the sine of x. And you might say, sir, how you know that identity? Now, it might be difficult to remember it. And if you can't remember it, you can actually use some numbers. Use some numbers, Marika. Look at this. If I take out my calculator, let's look at the sine of pi, which is 180 minus 45. The sine of 180 minus 45 is root 2 over 2. And if you were to just look at the sine of 45, you're going to get the same root 2 over 2. Because sine is positive in the first and the second quadrant. So that's how that rule come into play. So all you have to do is remember, say, when you draw your circle, ask yourself, are we pass sine positive again? Here so and here so. So if the angle in the first quadrant is A, the answer in the second quadrant is pi minus A. Oh, so that means that the sine of A equal to the sine of pi minus A. Oh, that makes sense. Yeah, man, for true. Right, Marika? She said important for know module 2 and module 3. Right?
Yes, sir.
Nice. So that's the first part. We're not really doing it yet still, but we'll get a 2 marks. Now it's a hence, show that the integral of 0 to pi of this is pi minus this. Now, Marika, really, all I did is break up the integral. All I did is expand the bracket. So get with 2 marks for the first part, then say hence. All we're going to do, Marika, is expand the bracket. So it's a part 1, part 2. All we have to do now is say part 2, the integral from 0 to a of x sine x dx. We know so it's equal to, start with this now, it's equal to this, the integral from 0 to pi of pi minus x sine x. Like literally, that's where we start with now, pi minus x sine x dx. Then all we have to do, Marika, just expanding the bracket. This becomes now the integral of pi times sine x. So it's integral from 0 to pi of, let me erase this line. Probably can move it over a little bit, like here, so. This is now the integral from 0 to pi of pi sine x dx, and then we have minus the integral from 0 to pi of x sine x dx. And then that's it, we prove it. All those expand the bracket. That's the second part. Like really, expanding the bracket, they're giving 2 marks to expand the bracket. When you're doing this question, you can tell them, say, really? C-sec stuff? Just ask them, really? Just to expand the bracket? Really? They want us to expand bracket now? Really? Right? You can ask them that, that's too easy. Now the last part we can appreciate now is to integrate. Show that the integral from 0 to pi of x sine x dx is pi. So pretty much we just need to finish this question now. Show them so the integral work out to be pi. So first we can start with what we know. We can start with the fact that the integral from 0 to pi of x sine x dx, we know that it is now the integral from 0 to pi of, looking back at the result we wrote down, I think it was pi sine x. This is now pi sine x dx minus the integral from 0 to pi of x sine x dx. Right, Marika? Cool it is? So
Yes,
now,
sir.
Marika, look at this now. Now, you might look at this and you probably say, sir, integration by parts this? No, we don't have to use integration by parts. You could, but if you look at this, Marika, if you call the integral of x sine xi, if you call this integral I, what you're going to realize is this is I and this is also I. So I is equal to the integral from 0 to pi of x sine x dx, and then this is just minus I, though, Marika? Then they're the same thing, though. X sine x, though.
Yes, sir.
Then we can bring over the I over here, so to say 2I is equal to, oh, this is not an x, this is a pi. So we can bring over the I now to get 2I is the integral of pi sine x. When you integrate sine, you get, or integrate sine, what we get? Or integrate sine, we get?
Yes.
Negative cos. Beautiful. I'm so happy you remember. So it's just going to be negative the cos of pi, and we integrate that. Negative, sorry, why am I writing so much? Negative pi cos x, and then we plug in the limits from 0 to pi. It's that simple. So now when we plug in the limits from 0 to pi, what that means is 2I is, plug in pi now, Marika, what's the cost of pi? What's the cost of pi? What's the cost of pi? Cost of 180? So it here the cos of 180, cos 180, negative 1, right?
Yes, sir.
So the cos of 180 is negative 1. So we're going to get negative 1 times pi is negative pi minus, so we'll plug in 0. The cos of 0 is 1, though. So we'll get minus minus pi, right? Right, Marika?
Yes, sir.
Yeah, man. That's it. All right. So now what we're going to wait, this is minus and minus. So we'll get, wait, the cos of pi is negative 1. So this should have become positive pi, sorry. So now we don't have pi minus minus pi, which is 2 pi. So Marika, when 2 pi is equal to 2i, so 2i equal 2 pi, so we can divide both sides by 2, and so that implies I is equal to pi. But remember, what did we call I? I was this integral right here. All right, so you have to tell them so where we call where I is equal to the integral of 0 to pi of x sine x. So that proves that the integral from 0 to pi of x sine x dx is equal to pi. Cool with this, Marika?
Yes, sir.
So in unit 2, you'd have had to done this using integration by parts. In unit 1, we said that we can do it by what's known as substitution. You can replace the variable x with a minus x. You see that? Nice. So cool with this, Marika?
Yes, sir.
So this paper wasn't bad. How did you find this paper?
It wasn't too bad.
Too bad. Good, good, good. So I'm going to post the mock exam, all right, for unit 1, all right, and you can submit by next week. I'm going to post it, and then tomorrow we'll go through unit 2, then I'll post the unit 2 paper, all right? Oh, and remember, you still have that mock exam for unit 2 to finish for me, all right?
Yes, sir.
All right, all right. So take care, Marika, and have a good night, and I'll see you tomorrow, all right?
Yes, sir. You too.